Hey guys, Buildzoid here, and today we're going to be taking a look at another DDR5 overclock with Ryzen 7000. This time the system is a 7800X3D on a Gigabyte X670E Aorus Master, and the memory kit is a Kingston Fury 7200CL38 kit. So technically this is a bit of an underclock. Oh, and it's also 2x16 gigabytes, but you know, I assume you have eyes and you know how to read. Actually, that's asking a bit much for the average YouTube viewer, but you know, I can hope that you can read. Anyway, the motherboard was provided by Gigabyte, so big thank you to Gigabyte for providing the board. And the CPU and the memory kit were purchased by me, so big thank you to the channel supporters for making those purchases possible. Anyway, yeah, so that's the system spec. We've got a single rank Hynix 8i based memory kit. It's 7200 because I don't have any lower spec Hynix 8i based memory kits. You can get Hynix 8i and even like DDR5-6000, and I think at this point probably even DDR5-5600 rated kits. But the easiest way to find, like, get 8i reliably is like high speed, relatively low timing memory kits. So we're talking like DDR5-6600 or higher. Um, because 6400 is not actually that challenging for, say, Hynix MDI to do. And also, these days, you can find some very loose, like, high-speed kits from, say, Corsair that use Micron memory chips, and those are like 6800, but with atrocious timings. So that also exists these days. But anyway, this is a single-rank Hynix 8i kit, and I just wanted to see how, you know, like, what I could do with 8i. Also, there was some like I recently learned that 8i can actually do one of the primaries a lot tighter than I ever bothered to try. So that's kind of what motivated this setup, like testing out this setup. Also, I wanted to see how good the memory controller on the 7800X3D is. And it seems to actually be the worst memory controller I have gotten on a Ryzen 7000 CPU so far. Um, Anyway, so yeah, let's just get it. Oh, I guess I should also talk about the cooling configuration. There's no fan on the RAM. Yeah, like this doesn't need any. Well, technically there is airflow from the radiator that's cooling the CPU. With the 7800X3D, we're not pulling a lot of power. That air is, you know, basically room temperature because the CPU doesn't produce any heat. So technically there's, you know, some airflow. This isn't like completely passive memory cooling, but at the same time, it's not like I'm putting extra effort into cooling the memory. Um, so yeah, and then for the CPU cooling, it's just a 240 millimeter Asetek AIO with, like, back when Arctic was still rebranding Asetek AIOs. So anyway, that's the system setup. Now let's take a look at the settings I ended up at. And like I mentioned, the memory controller on this CPU is, like, there's a small chance that it's a motherboard or BIOS issue, but I'm pretty sure it's actually just the memory controller because I've, like, with other CPUs on this board, I've had no problems running, like, say, DDR5-6200, which is where I would expect most Ryzen 7000 series chips to sort of top out at. Well, really, somewhere between, like, 6200 and 6300 is where most chips will stop. But yeah, this chip, like, technically it boots at 6200, and it kind of works at 6200, but it's really weird. Sometimes it doesn't retrain. Infinity Fabric overclocking kind of doesn't work. Like, it's strange. Like, at 6200, this CPU just has a lot of weird issues, as far as I can tell. And originally I thought, oh, maybe if I like, because I actually used the CPU with an MDI kit for some other testing, and I was running that at 6200, because, you know, MDI, ADI at DDR5-6, that, like, in these low speeds, you don't really see a difference in terms of the speeds that those memory chips can hit. But yeah, this chip at 6200 is just not very happy, and I've not been able to figure out why. Like, I've tried more like voltage combinations with this CPU than I've tried with any of the other Ryzen 7000 chips that I have, and 6200 just has weird issues with stability, and it's just first time I've seen that with a Ryzen, because usually, like, my experience with the other CPUs has been, if you're at a speed that doesn't want to work, it just doesn't work. It's not like temperamental where it's like, oh, it kind of works and then it doesn't, or it works and then you reboot and then it doesn't, or like So yeah, anyway, I gave up on 6200 because in the grand scheme of things, 200 megabits per second is not going to massively change the overall performance. So anyway, we're at DDR5-6000, which I am a bit like I was hoping to push it further, but I'll take it, I guess. Well, more like I like to tell myself that the fact that this chip can do 2200 somehow compensates for the lower memory speed, but unfortunately that's not really the case in my experience. With the other CPUs, generally speaking, running higher memory clock, lower Infinity Fabric gives you better performance than high Infinity Fabric, low memory clock. But either way, it is kind of neat that the Infinity Fabric on this chip is just ridiculous. And it really is ridiculous because, first of all, it does 2200, right? Like, it's passing LinPack, no weird performance anomalies. Well, I mean, if we scroll all the way to the top, you'll notice that it ran at like 391-ish gigaflops, and then it started running at 392. And the reason for that is I opened the window while running LinPack because the room was getting kind of warm, and so I opened a window, and then the room was cooler, and the CPU boosted a bit higher, so the gigaflops went up a bit. But ultimately, there's no like weird performance regressions. In fact, this I want to say it's delivering more gigaflops in LinPack than when I was trying to get 6200 to work, but that's probably because when I was trying to get 6200 to work, I was also running incredibly awful memory timings because of all of the weird stability issues, and I thought like, well, maybe I just suck at memory timings, but nah, the CPU's memory controller is just weird about running 6200 because even with like borderline auto timings, the stability never really cleared up. But yeah, so no weird anomalies in terms of performance in LinPack. It ran a ton of Y-Cruncher of the N64, HNT, and VST tests. So yeah, like we're at 33,000 seconds because I just left it running overnight. 2,000% of HCI mem test, and then an hour and 40 minutes of test mem 5. Honestly, I kind of feel like I could have run test mem 5 for longer with how long the other tests have been, but it's just sort of a different load, and yeah, I could have increased the cycle count, but I don't like there's like a day worth of like Y-Cruncher and HCI mem test here. So I'm not too fussed about the kind of short test mem 5. But yeah, so this chip does like 2200 Infinity Fabric, and what's actually kind of crazy is this chip, if you're just running benchmarks, it can actually kind of do some benchmarks at 2233, which like is so much better than any other chip that I have on hand. Like all of the other 7000 series chips I have, they tend to top out around like 21 21 like yeah, like 2100 to like 2166 on the Infinity Fabric. Right, and even at 2166, depending on it, like if you don't set the settings just right, they might not be stable. And then there's this chip, which just like it does 2200 passing all stress tests, and then it does like 2233 kinda, which is just like that doesn't even post on a lot of the other CPUs. That's not even like, oh, it you can get into Windows at 2233 and it's not stable. No, it's like it just doesn't work at 2233 at all, and this chip does. So yeah, in fact, this chip at 2233 is like more stable than the 17900X at 2200 Infinity Fabric. Which yeah, the Infinity Fabric on this chip is insane, which makes me, I guess, even like that makes it kind of more upsetting that the memory controller isn't better, right? Because if you could run both of them at very high speeds, that would be even better than having like DDR5-6000 and then crazy Infinity Fabric. But hey, I'll take what I can get. And yeah, this chip's Infinity Fabric is just insane. Just way better than any other Ryzen 7000 I've tested so far. And so that's really, really cool. Anyway, we're going to put more effort, like we're going to go into more detail with the timings when we get to the actual BIOS, which will be very soon. But as you can see, like we're at CL28, and then the main thing was that apparently ADI does low TRP timing. Yeah, apparently it does. So we're right now at like 6,000 CL28 and then 36 for TRCD. I don't know why they have TRCD down here. This is so like, no, like the standard for reading out memory timings has always been like TCL, TRCD, TRP. And then there's AMD's software where we go TCL, TRP, TRCD somewhere down at the bottom. It's just like, I have no idea why. And personally, if I had my way, TRCD would be first, because in terms of the order in which operations are done on the memory, activate commands go first. But anyway, also TRCD is generally more useful for identifying memory chips than any of the other memory timings. But anyway, actually, that's not true. It kind of depends on the generation of DDR you're talking about. But TRCD is kind of like it help. It's I usually care more about TRCD than the other timings. But anyway, yeah. So that's kind of the setup that we're looking at here. Is just like not really that great memory speed, but relative like rather tight memory timings, and then just an insane Infinity Fabric clock. Um, and of course, there's also no errors in the like Windows hardware error thing for hardware info because it's Ryzen. I've literally not seen it produce any errors. Actually, I think with Curve Optimizer, it sometimes spits out like errors for Windows hardware errors, but I'm not doing any Curve Optimizer here or anything. So, yeah, this is just a memory control, like memory overclock with, well, not really, again, DDR5-6200 XMP memory kit, but, so not really a memory overclock, but, where was I going with that? But like technically, so just a memory controller overclock, right? No actual CPU adjustments whatsoever. Anyway, so yeah, that's the setup here, and now let's go into the BIOS and take a closer look at what went into this. So anyway, here we are in the BIOS, and yeah, so SoC voltage, we're at 1.2 volts. One of the main things that I've discovered with Ryzen 7000 is that if you want to run a high Infinity Fabric clock, you need to run a low SoC voltage. And the kind of annoying thing about that is that your actual memory clock itself generally scales with SoC voltage. So like on most CPUs, if you want to run a high memory clock, you need a lot of SoC voltage to do it. Which directly harms your ability to clock the Infinity Fabric. So yeah, but considering we're just at DDR5-6000 here, we don't need a high SoC voltage for memory stability. So yeah, it's possible to actually run just an insanely high Infinity Fabric clock. Though I did have the SoC voltage as high as like 1.3 volts when I was trying to get 6200 to work, and it just kind of didn't. So that's why, I was messing. Like I really tried a lot to get 6200 to be somewhat like reliable, and it just wouldn't. So yeah. Also, this CPU needs like at least 1.25 volts for 6200 to work like even remotely. Right, like at 1.2 volts, it will not even get into Windows at DDR5 6200, but it's kind of expected. Is like, well, actually, it's not necessarily expected. I'm pretty sure I have some CPUs that can do 6200 with 1.2 volts, but yeah, this is not one of them. The memory controller on this chip really does seem to just absolutely suck. Another thing that's kind of interesting about this chip is for some reason it seems to like extra VDDIO memory voltage, which yeah, I can't say I've seen on any of my other chips. But when I was trying to get 6200 to work, that helped. It didn't fix it though, so that's why I eventually reverted to back down to like 6000. But I left the VDDIO higher because, well, if it were helped at 6200, it should also be helping at 6000. Anyway, for the memory voltage, we're up at 1.43 volts. Now, the reason it's 1.43 volts is because Gigabyte's F10 BIOS on this board, yeah, we're on F10. Yeah, this BIOS doesn't have, the high memory voltages are broken again. Like, I would have originally really wanted to, like, push maybe 1.5 volts or higher for memory VDD to try push the memory timings even lower. But the board fails to train, right? You just get that 15 to C5 postcode loop, and then it doesn't post. So that's fun. I was kind of like when I first ran into that with this BIOS, I was maybe thinking like, oh, maybe it's like a power management IC incompatibility between the memory kit. But I've tried several memory kits at this point. None of them work at high memory voltage. So I'm gonna go with like Gigabyte just broke the memory training or something again, or like AM. Well, yeah, no, this has been a recurring issue for me with Gigabyte boards is that like on some BIOS versions, high memory voltages just don't work. Now that could be because like AMD changed something in the memory training procedure, and then Gigabyte didn't come up with a workaround for it, or Gigabyte accidentally forgot their workaround or something. But either way, high memory voltages don't work. So that's why it's at 1.43 volts, because that bug kicks in as soon as you go outside the sort of like default JDEC voltage range, which goes up to 1.435 volts, right? If you have a locked PMIC, which this memory kit doesn't. This memory kit literally comes with a 1.45 volt XMP, which is why I decided to use it. It's like it has a high voltage XMP. Like this should support high memory voltages. No, it doesn't. Um, so yeah, so 1.43. I mean, technically, I could have used 1.435 and that would have been fine, but like 5 millivolts isn't gonna drastically change the results of what I'm doing here. And now I've lost my freaking setting. Um, but yeah, like 1.435 and 1.3, that's not really gonna make a huge difference. So I just went with 1.43. But yeah, that is kind of frustrating that like there's this on-off bug with Gigabyte boards right now, whereas just like on some BIOSes you can run high memory voltages, and on other BIOSes you just kind of can't. And this BIOS is one where you just kind of can't, so I'm not. And 1.43 is like below that threshold of like the board stops being able to post. Um, Anyway, for VDDQ, we're at 1.3 volts. I generally run VDD-IO MEM and VDDQ at the same level because these are both sort of I/O voltages. So this is like the voltage, and I'm not 100% on this, but as far as I know, this should be the voltage that the memory controller uses to talk to the memory sticks, and then VDDQ is what the memory uses to talk back to talk to the memory controller. Um, so yeah, that's why I usually keep them at the same voltage levels, because it just kind of makes sense that that would work optimally, though it's not necessarily true. So like you might see benefits from trying to set them separately from each other, but like this works, right? It passed all of the stress tests, so I'm going to leave it at that. Also, what's interesting is on a lot of newer BIOSes from Gigabyte, running high VDD-IO MEM and VDDQ just doesn't work. Like running these at like 1.4 volts or something, yeah, that doesn't tend to work very well for stability. So yeah, there's definitely been something about the memory controller like configuration has been changing with the BIOS updates, because on like I'm relatively certain on earlier BIOSes I was actually setting like VDDQ and VDD basically to the same value, and it worked just fine. And then Gigabyte put out a BIOS update where the VDDQ and VDDIO would default to 1.25 volts, which it didn't used to. And then since that BIOS version, basically setting these super high doesn't really work anymore. Not that there's like a like real reason to do that. It's just kind of like interesting like thing that I've noticed where it's like, oh yeah, you generally don't want to be using high VDDQ and VDDIO MEM with Gigabyte boards. Other manufacturers, you might find that higher values work just fine. Anyway, there's no reason to adjust DDR VPP because it doesn't really do anything, so that's just on auto. And for advanced voltage settings, I think I do have I have the VDDG voltages bumped, so this helps with the Infinity fabric stability, so CCD voltage is at 1050, IO voltage is at 950, so these are millivolts, right? So it's 1.05 volts and 0.95 volts. And you can't set these two voltages any higher than 1.1 volts unless you raise your VDD MISC. Though in my experience, like trying to raise them like really high doesn't tend to do anything. Like if by 1050 you're not getting your Infinity fabric stable, raising it more probably won't change that. In my experience. So yeah, that's also like a lot of this is just kind of like down to silicon lottery. Like if it doesn't work by a certain voltage, then it's just never gonna work, right? Kind of like with this CPU, or like, well, 6200 doesn't work at basically any, like doesn't properly work at any combination of SoC and VDD-IO MEM and VDDQ, so I give up and go back down to 6000. right? Whereas the FCLK just kind of goes like it's almost fully stable at 2200 with like auto voltages. And then if you just set it, if you just bump the VDDG CCD voltage up to 1050, yeah, it does 2200 completely fine, which is kind of ridiculous because like other chips require that VDDG voltage bump just to do like 2166 or something. So, yeah. Anyway, also UCLK equals memCLK because the /2 option just yeah, well, it doesn't tank performance like it used to on Ryzen 5000, but it's still worse, right? Because on Ryzen 5000, the problem with the UCLK equals MCLK divided by 2 is that it also desynced your Infinity Fabric. On Ryzen 7000, the Infinity Fabric is permanently desynchronized, but that doesn't mean underclocking your memory controller is a good idea, right? Because the UCLK, that's the actual memory controller clock, and so when the memory control, like you want the memory controller to be clocked as high as possible because it's just more performance, right? Like the data arrives at the memory controller, and then it has to get onto the Infinity Fabric. Well, if the memory controller is clocked higher, that happens faster. So, like UCLK equals MCLK is like less harmful than it used to be on Ryzen 5000 because back then you had like you had the latency penalty of the memory controller getting underclocked and the latency penalty of the desynchronization with the Infinity Fabric. With Ryzen 7000, you only have the memory controller underclock penalty. You don't have the desynchronization penalty because the Infinity Fabric is never synchronized. So, you can't desync something that was never synchronized in the first place. Um, like it's always desynchronized, so there's no extra penalty for that. So, but yeah, either way, generally you don't want to be using UCLK equals MCLK because it's not great for performance. It's not again. Well, yeah, no, you should just as far as I've not seen. Well, maybe Y-Cruncher. Like there are certain workloads that are primarily memory bandwidth bound, and in those workloads, this can actually kind of work. But at the same time, I've not really noticed it significantly improving memory clocks. Like if the CPU doesn't do or more like my experience has been that the memory controller clock doesn't really seem to be the limiting factor of the memory clock that you can run. So like underclocking the memory controller doesn't improve memory overclocking headroom. Um, is the best way to summarize it. So yeah, I don't really see any reason why you'd ever want to use this, except maybe if you were going for a frequency validation, but I don't know why you'd be doing that with an AMD CPU because these memory controllers don't clock that high in the first place. So these memory controllers can't clock the memory that high anyway, even if you're in, UCLK equals MCLK/2. Anyway, apparently I forgot to disable power down mode. Oh, right, that's also part of the whole, like, I'm trying to get 6200 to work, because power down mode can sometimes cause weird stability issues on certain BIOS versions. Generally speaking, you want this disabled because it slightly reduces your memory latency, because the power down mode basically puts the I/O portion of the memory chip to sleep to save like a fraction of a watt. The downside to that is that then you have to wake up the memory chips, and well, that takes time. So it's better if it's just like if the memory chips just never put the I/O to sleep. You have like more. It's not really. You have slightly less memory latency on average, right? Because you avoid that scenario of like, oh, you might have to wake up the I/O. So, um, anyway, so generally speaking, this is something you would want to disable if you could disable it. I just bumped the HDMI cable. I did that again. I'm an idiot. Well, I bumped it and then I went to readjust it. So, anyway, yeah, this is generally something you would want disabled, but apparently I just kind of forgot to disable it after messing around at 6200 and failing to get 6200 to work. So yeah, that's on auto. I'm not rerunning all of those stress tests. That took like a day. Though, yeah, like I would, well, I would recommend that you generally try to disable this, but you might run into stability issues. And one way you can try fix those is if you go into the AMD CBS and then, where is it? UMC, yeah, so DDR options, and then you go to DDR memory features, memory context restore. Sometimes you can fix the like power down enable instability by disabling memory context restore, which doesn't really make any actually. I wonder if it's because like when the I/O gets no, you shouldn't have to retrain the memory. Like, which is weird. That's like a weird AMD AGSA thing, but like potentially disabling this might fix your ability to also disable power down mode. Now, the downside to disabling the memory context restore is that your boot up is going to be longer because the memory control, like it's going to be retraining the memory every single time. Though it's worth noting on some motherboards, the memory context restore on its own is unstable. Like just having this enabled will eventually lead to like after multiple restarts, the system will restart and it just won't be stable anymore. So yeah, but that also like depends on which exact AGSA version you're on because like AMD is trying to get basically like for a period of time, power down mode was like like the ability to turn off power down mode was removed from Gigabyte motherboards because it wasn't like officially supported by the AMD AGSA. Like you had like early BIOSes that had power down, and then they removed it, and then they put it back in. So yeah, AMD is like still working on like dialing in the memory controller, and the side effect of that is things sometimes get broken. So yeah, other than that, we have gear down mode. Also, this can improve your performance a bit if you disable it. It also tends to have a huge stability penalty. So I don't generally, because this compared to power down mode is like a very negligible negligible performance gain, but potentially huge stability problem. And this isn't like, oh, you just disable memory context restore and then it's fixed. No, no, no. This is like you might have to manually configure all of your termination settings, which on DDR4 wasn't very fun, but on DDR5 is significantly worse because there are now more termination settings than there was for DDR4. So this is one of those things like you can try disable it, and if it doesn't work, then just leave it on auto because, yeah, as far as I'm concerned, this one is like not worth the effort. Anyway, so now I just went totally way too far on like power down mode, memory context restore, and gear down mode, but I like power down mode. Generally, you want to disable it. Gear down mode is kind of like it's neat if you can, but I wouldn't generally bother because it can be a massive pain, like absolute nightmare to like get this working. Though sometimes it does just work, and if it does just work, then there's no reason not to use it, but like not to disable it. But generally, I would just kind of leave it on because it doesn't like. Yeah, like the potential stability issues are, in my opinion, not worth the slight performance uplift. Anyway, let's take a look at the timings. So, primaries, we've got 28, 36, 28, and the thing is, like, CRP might actually go even lower than this. But this is the main thing that, like, I'm not the one who discovered this. I learned this from somebody else, and I don't know who actually was the first person to try low TRP. But yeah, Hynix 8i does low TRP, which is pretty neat. And in fact, I'm not entirely certain that right now this is minimized. Like, it might go even lower. I didn't test 26, so 26 might work. But yeah, I just wanted to test if like low TRP, you know, like I heard, hey, this is a thing, and so I was like, well, let's go test the thing, and yes, it is a thing, and it does work. Potentially, it could go even lower. So that's kind of neat because that, you know, just, it's not a huge, like TRP out of the primaries is arguably the least important. Well, no, I think TRAS is less important than TRP. Yeah, TRAS is less important than TRP. But yeah, so not exactly a super important timing, but it's just kind of neat that you can run it really low. Also, I like the fact that we've got like DDR3 style looking timings, right? Where you have like low cast latency, high TRCD, low TRP. That was like super common on DDR3 where you had like 9119 kits or 787 was really common. I think I even saw a 79. Yeah, you had like 797. I think 686 was a thing, right? Like you had a ton of these just like low cast latency, high TRCD, low TRP memory kits, and so it's just kind of neat that you get variety in the primary timings instead of TRCD and TRP being exactly the same. But anyway, TRAS is at 30. Also, the low TRP means that we can now push TRC lower, so that's at 58. And I do really wonder if like TRP would go even lower, like 26 and then like 56 TRC. The thing is, you have to keep in mind that like another 2 ticks of anyone of like a tick or two of pretty much any memory timing on its own doesn't really do that much. So like 28 compared to 36, okay, that's kind of significant. But like 26 compared to 28, not so much. Um, though, yeah, I do wonder if like 26 wouldn't work, but I didn't test that, and I'm not going to rerun all the stress tests just to test that. Well, maybe I would just rerun HCI or test Mem5 just to test that, because Y-Cruncher and LinPack are really more for the Infinity Fabric. This isn't like the Intel memory controller where it just kind of falls apart under high load. At least I've not seen Ryzen do that. Like that seems to be an Intel thing where it's like, yeah, it passes everything, and then you throw an actual CPU workload on the CPU, and like you throw a heavy workload on the CPU and the memory controller falls apart, and it's just like, can you not? But anyway, this is Ryzen, so we don't have to worry about that. Refresh intervals maxed out at 65,000. TRFC is at 466. This might go even lower than this, but this is one of those timings where it's like, spending a lot of time tuning your TRFC in like increments of 10 or something. Like if you were insane, you could actually, test it in increments of 1 if you wanted to just spend forever tuning your TRFC. I wouldn't recommend it. Um, anyway, so like I think 450 might also work, but it's not going to be drastically faster than 466, so can't be bothered. Then TRFC2 and TRFC same bank aren't actually used by the AMD memory controller right now. Like straight up like these are for a like different refresh mode that AMD just doesn't use. So these two timings literally don't do anything for performance, and you can just ignore them, which is why they're on auto. Though if you want to be silly about it, you could also set them to something like, oh, I don't know, like 1337. That would also not affect your performance in any way. But when you share a screenshot on the internet, you might confuse some people. You could all actually, well, no, you can't set it to 999 because I think the limit is like 2047. But actually, is it 48? Oh, it's 48. Wait, it goes higher than that? Wait, what is the limit? Oh, it's 4095. Yeah, so you can just punch in like whatever number you like there. You could set it to 50. It won't do anything either. That's like the minimum value for that register, and AMD just doesn't use that refresh mode, which is kind of a shame because in theory that refresh mode should actually deliver somewhat better performance than using TRFC1, but AMD hasn't implemented it, so yeah. Those two timings currently don't do anything. Though I guess maybe in the future they'll add that functionality to the memory controller, assuming it even supports that as an option at all, right? Like just because the timings are there doesn't mean it necessarily has the ability to do it. But anyway, RTP's at 12. This could maybe go lower, like a 10 or an 8, but I didn't really feel like testing that. TRDL at 8. I think actually at 6,000 it might have done 6. I think this is a leftover of my attempts at getting 6200 to work. Luckily, the TRRDL timing is like far. So TRRDS is the timing that the memory controller will try to use as much as possible. TRRDL is the timing that the memory controller will try to avoid using as much as possible. So having a relatively loose TRRDL is far less of an issue than having a like loose TRRDS. And it's also worth noting with DDR5 that the burst length is 8 cycles. So having a TRRDL of 8 actually doesn't have like it because like 4 is faster. Okay, like this is very slightly faster, but the reason isn't because you can like do more operations back to back, but because you can queue up more commands in less time if your delay between activate commands is shorter, right? So there's like a scheduling benefit to having a lower TRD, even if like it doesn't directly allow you to queue up like more read commands in less space. Like it doesn't do that. But it does allow the memory controller to be a bit more flexible with queuing up memory timings, which is why you want these timings as low as possible, even if they don't directly translate into just like straight up read write command, queuing. Whereas like going from like a 12 to an 8, that actually reduces the delay between two read commands potentially. But going from like an 8 to a 6 doesn't actually change the delay between two read or two write commands at all. It just affects the activate commands themselves. But anyway, so that's at 8.4, which in terms of performance, it's not really isn't that different from 4.4, right? But yeah, arguably I could have tightened that timing. So if you know, and like, well, the thing is, it depends on the kit. Like I've seen some memory kits where you can run 4.4 no problem, and then there's some, and this isn't even consistent to like A die or M die. This is like random with both A die and M die kits. Like I have an M die kit that doesn't like low TRRDL, and I have 8 M die kits that do 4.4 at like any speed. So yeah, and actually, if you just shove enough voltage into some kits, you can do 4.4 on them as well. But then on this BIOS version, we can't go above 1.435 volts, so that's not really an option for forcing low TRRDL. Anyway, T falls at 20, which is the register limit for the AMD memory controller. Like, you literally cannot set this timing lower. At least according to AMD. I know there are some motherboards that'll let you set TFAW below 20, but I don't actually know if the memory controller respects that, right? Like, that's the thing. Just because you can punch something into the BIOS doesn't mean that the CPU is actually going to do it. Anyway, then we have WTRL, which is at 16. I'm relatively certain it doesn't go any lower than this, but I've not bothered to test and check. Then we have WTRS, which is at 4. I am quite like this is another one that I don't really. I think I've tried it at 3 in the past and it doesn't work. Anyway, at this point, we're sort of looking at like generic Hynix timings. Oh, I could have run WRD at like 3 instead of 4. Yeah, there's some like unfortunately some of these timings are leftovers of me desperately trying to get 6200 to not be weird about stability, but I never succeeded at that and then forgot to like fix all the timings. So we have some leftovers. Because I'm relatively certain I ran 6.4 at 6000 and it was passing at least test mem 5. That wasn't like a full batch of stress tests. That was just like one stress test. But with Ryzen, my experience so far has been basically if it passes one stress test, it passes everything. Well, with the exception of like if your Infinity Fabric's too high, then it might fail out on LinPack or Y-Cruncher, but the memory side of things, it's like if it's not erroring in LinPack, then it's not going to error in HCI, and if it's not erroring in HCI, it's not going to error in testmem 5. It's just not really going to error anywhere, right? So, yeah. Anyway, our read-to-read SCL at 4, that's generally it. Yeah, I think that's as low as it goes. Write-to-write SCL at 2, which is just Hynix timing, like Hynix things. You can do really short write-to-write, which is kind of neat. And then we have TWRRD and RDWR at 4 and 16, which is just sort of like I'm kind of annoyed by the 4. That could have been a 3, but this is usually what I go with for Hynix memory kits. Well, other than the 4, but yeah, anyway, and then we have the like read-to-read SD and read-to-read DD timings and like write-to-write SD and DD. And these both stand for like same DIM and different DIM. But the thing is like this is like read-to-read same DIM, different rank. And this is read-to-read different DIM, right? And the thing is the system, we've got one DIM on each memory channel. So there isn't a different DIM. And each of these DIMMs is a single rank DIM, so there also isn't a different rank on each memory channel. So the same, like the different rank timing and the different DIM timings are completely irrelevant to this setup. Therefore, they're on auto because they don't do anything. Anyway, if we keep scrolling down, we find a bunch of settings that I've left on auto because there's a lot of them and I don't feel like dealing with them, right? So we've got like drive strengths and termination settings here. And arguably, if you're trying to get something like gear down mode disabled, you'd have to mess with these. But like these are brute force trial and error, and they can be quite like configuration specific. Like they can be specific. They are definitely motherboard specific in a lot of scenarios. They can also vary depending on the memory kit you're using and what voltages you're at. And like if auto is doing an acceptable job, which it is because it's, passing all the stress tests, it's not like there's no stability issues. Sure, I have a gear down mode on auto, which I don't actually know if that means it's disabled or not, but I would rather not have to deal with these. So, yeah, because what you need to understand about these is these are all basically like signal integrity uh, settings. So the point of tuning these isn't like these don't give you more performance. They're basically to clean up the quality of the signal on the data bus, as well as like the command address bus. And the thing is, there is a lot. Well, like the memory controller should do a okay job of setting these itself, right? That's actually what memory training is about, is mainly configuring these, as well as some hidden settings that we can't actually see in the BIOS because, yeah, they're just not available, but because AMD doesn't want to make them available. But yeah, so I don't really want to deal with these because the thing is, these are brute force trial and error, right? Like you really don't have any way of knowing if like an adjustment you've made to these settings is actually good until you run a stress test and the stability either improves or it doesn't. Though admittedly, if you set them really, really wrong, the system just won't post, right? So I guess there is that like, oh, you can eliminate some settings. But the thing with Ryzen right now is that like I've not like on this motherboard, it technically has where is it? Yeah, it has this like safe mode option. I've never gotten it to work ever. Just absolutely just does not work. And because that doesn't work, messing with the termination settings and the drive strengths, where it's like, oh, if you set these wrong, the system won't post, and then it won't like recover automatically because that barely ever works. Means you'd be doing a lot of clear CMOS. I don't really feel like going through that, especially since each of these has a lot of options, right? So yeah, technically speaking, there is like some very, very fancy, expensive test equipment that could be used to like figure out optimal values for all of these. I don't have access to that kind of equipment. In fact, there is very few people who have access to that kind of equipment, and they basically all work at motherboard manufacturers or like, well, okay, that's not true, but like it's like we're talking like $100,000+ oscilloscopes if you want to be able to analyze the signal quality of a DDR bus or at least a DDR5 bus. I think if you went like DDR1, you might get away with something cheaper, but yeah, for DDR5, like you're gonna need some really high-end test equipment if you want to like actually see what you're, change like what adjusting these settings is actually doing is not really an option. So you're basically just stuck with brute force trial and error, and there's a lot of settings to brute force. I do not recommend it. So, yeah. Anyway, so that's the setup. I think the main takeaway here is like if you have a Hynix 8i kit, you can like try to run a low TRP, and then you can also run low TRC with it. And then also like, hey, if you get lucky, you can do like crazy high FCLK. And if you get unlucky, your memory controller gets stuck at 6000. So yeah, though I do still need to test the CPU with other motherboards. Maybe on a different board I could get 6200 to actually work. Though again, I've had 6200 work just fine with other CPUs on this board, so I'm kind of leaning towards this being a memory controller issue than a board issue rather than a board issue, but I'm not going to rule it out just yet, because the only way you can know for sure that it's not a like board issue is if you try, because I've tried different memory kits, so I know it's not the memory kit. I haven't tried a different board yet, so I don't know if it's a board problem. Right, it's kind of the annoying thing with memory overclocking is there's a lot of variables, and not like how do you prove your motherboard is bad? Well, you need to get a better motherboard, right? And then if you try a bunch of boards and they all behave the same, then it's like, oh, that's a memory controller problem, right? Anyway, so I haven't like done a bunch of memory overclocking with this chip on a bunch of different boards. So yeah, I'm gonna be trying that. Hopefully one of them does 6200. But yeah, if nothing else, like this, the Infinity fabric on this chip is kind of crazy. So yeah. Anyway, that's it for the video. Here's the system specs once more. So thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with the channel, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store where you can pick up shirts, hoodies, posters, you know, the usual YouTuber merch. And I've also got a Bandcamp. There's a link to that down in the description below as well. And that's it for the video. So thank you for watching and goodbye.